Welcome to application of calculus, and that's question 10. And then we have the equation of the speed and the rate of change of time given in t. And what we have s prime t, whereby equation is minus t squared plus 18t, and then that is our quadratic equation. So they say they need maximum speed. So at max, we know we need to draw a quadratic graph. We know that t there, okay, when t is 0, y is 0, and we know y is s prime t. So that is s prime t, that's y, and then our x is t, and then so which means s prime t, the first derivative of st is going to be y, so x is t, and then when it's 0 0, and then that's our maximum point. So at our maximum point we have we need to find our t. So our t there, which is it's gonna be minus b over 2a, and then we know that our a is negative 3, and our b is going to be 18. So our b is 18, and then minus bracket minus 18 over 2 bracket minus 3. Our a is minus 3, so that's 18 over 2 times minus 3 is 6, and then our t is going to be 6, and 18 divided by 6 is 3. Our t is going to be 3, so at max t is 3. Okay, so coming back from the original equation, substituting t there, so that's going to be minus 3 bracket 3 to the power 2 plus 18 bracket multiplied by 3 bracket 3. So that's going to be, using a calculator, that's minus 3 to the power 2 plus 18 multiplied by 3. So our equation is going to be 27. So that's going to be 27 right there. So it's 27 kilometers per hour. So that's our answer for the first question. So the second question, I just use integration. So integration is just the reverse of differentiation. So the start at p, end at t. So what's the distance? And let's again come to the graph and then stop at t. So speed was 0 at max, that we know that t is 3 at max, and then it's symmetrical, so 0 kilometer, actually it's time, 0 hour up to 6 hour. Okay, so that means final minus initial, so that's change in time, and that's gonna 6 minus 0, so that's going to be 6 hour. Okay, 6 hours. So and that means that we have s prime t is going to be minus 3t squared plus 18t is equals to speed. So that's our speed, given speed, and from there we integrate that minus 3t squared plus 18t. So when we integrate that, that's going to be minus 3t 2 plus 1 there, so we divide the term by 2 plus 1, and then plus 18t 1 plus 1, we just add 1 on the exponent, and then divide by 1 plus 1, so that is going to be 3t to the power 3 over 3 plus 18t to the power 2 over 2 plus c, which is a constant, and all that is going to be our distance. Okay, that's our distance, and then from there we know that what do we have? So that gives us negative 1, so it's negative t to the power 3, that gives us 9, so that's going to be 9t squared plus c, and all of that is going to be s Okay, and then from there we know that that's equals to distance, right? So when you take distance, first derivative is going to be speed. So when when the distance there is 0, so when distance is 0, t is 0, so that means that the start is 0 kilometer. So it's going to be when substituting 0 there is equals to 0 when it's 0, so t is 0 to the power 3 plus 9. We're using that equation there. So when t, we're substituting t for 0, so t is gonna be 0 squared plus c. So at the start, when time is 0, that's when you start, so that means is 0, so that means c there is 0. So we don't have, our constant is 0, we don't have any constant. Then that means there what we have to do now, we're going to write the original equation there, which is minus t to the power 3 plus 9t to the power 2. Okay, so s when x6 maximum hour, remember that is point t p, and the final point is point t, so it takes 6 hours to get there. So that's going to be minus 6 to the power 3 plus 9, multiplied by 6 to the power 2. So that will mean that we're going to have 6 to the power 3 plus 9 bracket 6 to the power 2, and that gives us 108. So it's 108, so it's going to be 108. Okay, so 108. So 108, that's our answer. Thank you for watching, and don't forget kilometer per hour.